Today I'll deliver topic to colloidal dispersions. Dispersed system consists of particle matter so known as dispersed phase distributed throughout the continuous phase known as dispersion medium. It is a classification of dispersed system, molecular dispersion, colloidal dispersion and coarse dispersions. First of all, molecular dispersion are the solutions of solvent in solvent. The solvent is a form of separate molecule homogeneously distributed throughout the solvent. Example, aqueous solution of salt and glucose. Second one is the colloidal dispersion. Microheterogeneous dispersed system, the dispersed phase cannot separate under gravity and centrifugation or other forces and particles do not mix or settle down. Example of colloidal dispersions. Aqueous dispersion nature polymer of colloidal silver salts jellies. Third of all, coarse dispersion are heterogeneous dispersed system in which the dispersed phase particles are larger than 0.5 micrometer. The concentration of dispersed phase may be exceeded 20%. Example of coarse dispersion, pharmaceutical emulsion and suspensions. Comparison of characteristic three dispersed systems. First of all, particle size. In molecular dispersion, less than 1 nanometer, and colloidal dispersion 1 nanometer to 0.1 micrometer. Cold dispersion greater than 0.1 micrometer. Appearance molecular dispersion clear transparent and colloidal dispersion appearance opalescent and cold dispersion appearance frequently opaque. आपला Visibility invisible in an electron microscope and visible in electron microscope and visible optical microscope. Diffusion. Under rapid diffusion, diffusion very slow, do not diffuse. Sedimentation, no aqueous of setting, do not settle down. First sedimentation of dispersed by gravity of other forces. Diffusion, undergoes diffusion, diffusion very slow and diffusion. It is chart is a very important throughout the lesson. Shape of colloidal particle. The shape of the shape dropped by colloidal particle is dispersion important because of more extended particle the greater it is specific surface then greater the opportunity of attractive force to develop between the particle of dispersion phase and dispersion medium. In freely environmental colloidal particle unroll and expose maximum surface area under adverse condition it rolls up and reduce the exposed area. The shape that can be assumed by colloidal dispersion are spheres, globules, short rods, prolate and ellipsoids, roughly ball-shaped, elongated, oblique ellipsoids, discus in shaped, flattened, and flux, long rods threads, loosely colloidal threads, branched threads. The following particle affecting change in shape and colloidal particle. First of flowability, sedimentation, osmotic pressure, pharmacological actions. Type of colloidal system. Based on the interaction between the dispersed phase and dispersion medium, colloidal systems are classified two parts. Lyophilic colloids and second one is the lyophobic colloids. They solvent hating. And lyophilic means solvings lovings. When loved together and bonding to each others. When the dispersion medium in a water, it is called the hydrophilic colloids, and it is the dispersion medium in organic solvent, it is called of hydrophobic colloids. Difference between lyophilic colloids and lyophobic colloids. Lyophilic colloids particles have greater affinity for dispersion medium, and lyophobic colloids particles have little affinity of dispersion mediums. Is the difference between greater affinity or little affinity? And owing that the affinity of dispersion medium, the molecule is dispersed spontaneously from colloidal solution. And lyophobic material does not disperse spontaneously, hence lyophobic source are prepared by dispersion and condensation method. This colloids from reversible source. This colloids from irreversible source. Viscosity of dispersion medium increase greater by the pressure lyophobic colloids particle. Viscosity of dispersion medium not greatly increased by the Presence of lyophilic colloids particle. Dispersion are stable. Generally, in this presence of the electrolyte, they may be salted out of high concentration by very soluble electrolyte. Lyophilic dispersion are unstable in the presence of even small concentration of electrolyte. Dispersed phase consists of generally are larger organic molecules such as gelatin, ascensia lying within the colloid size range. Dispersion phase ordinarily consists of the inorganic particles such as gold and silvers. Preparation of lyophilic colloids. Simple dispersion in a lyophilic material in a solvent leads to formation of the lyophilic colloids. Preparation of the lyophilic colloids. The lyophilic colloids may be prepared by two methods: dispersion method and condensation method. Dispersion method, this method involves the breakdown of larger particle into particle of the colloidal dimension. The breakdown of coarse material may be effected by the use of the colloidal mills. Ultrasonic treatment in the presence of stabilizing agents such as surface active agents. And condensation method, in this method the colloidal particle from the aggregation, the smaller particles such as a molecules, this involves the higher degree initial supersaturation followed by the formation of the growth of nuclei, and supersaturation can be brought about by. In this are the two methods: change in solvent and chemical reaction. For example, sulfur dissolved in alcohol and the concentrated solution in the pour into excess of water may small nuclei from supersaturation of solution. This grow rapidly from the colloidal solution. If saturated solution of sulfur in acetone poured solution into hot water, the acetone vaporizes, leaving a colloidal dispersion of sulfur. Chemical reaction, for example, colloidal silver iodine may be obtained from the reacting together dilute solution of silver nitrate and potassium iodide. If the solution of ferric chloride into boiled within the excess of water, produce a red solution of hydrolyzed ferric oxide by hydrolysis. Purification of colloid. When a colloid solution is prepared, it often contains certain electrolytes which tend destabilize it. The following method using the purification of colloids. First of all, dialysis. Dialysis at equilibrium of colloid material is retained compartment of where the subcolloids material is distributed equally on both sides. Material may be membrane continuously removing the liquid. Compartment in B. It is possible to obtain colloidal material in compartment A, which frees subcolloidal contaminant. Process the dialysis may be hastened by the stirring so as maintain to high concentration gradient of diffusion molecules across the membrane and by the renewing of outer layer of the time. Example, dialysis to particles to is particle to in a big compartment to coming larger particle to smaller particle. Ultrafiltration. Colloidal dispersion can pass through the ordinary filter because the pore size of the filter is a large. If this paper is impregnated within the colloidation, any syrup, solution, nitrocellulose, some etc. Pore size reduced such as modified filter paper are called ultrafilter. By applying pressure or suction that solvent, the small particle may force across the membrane but larger colloidal particles are retained. This process is referred to as ultrafiltration. This is the diagram of ultrafiltration. So clear to gas pressure, gas prepare, soil feed, and solution and electrolytes, compartment, colloidal imbrications, medium and electrolytes. Third filtration method is electrodialysis. In this in the dialysis unit, the movement of ions across the membrane can be spread up by applying the electric current through electrolyte induced in a solution. The electric potential increases the rate of movement ionic improved through dialysis membrane and so provide the more rapid means of purification. The dialysis membrane allows small particle ions to pass through, but colloidal size particle hemoglobin do not pass through the membrane. This is a diagram of colloid electrodialysis. Colloidal dispersions, waters, semi-permeable membrane to removal of colloids, waters, semi-permeable membrane. It is of semi-permeable membrane and colloidal dispersion. In a colloidal dispersion is a pass-through and a removal of colloidal dispersion. Is a water to water inlet and water outlet. So removal of colloids. Then association of amphiphilic colloids. Surface active have two distinct regions of opening of solution affinity within the same molecules or ions are known as amphiphilous. When present in a liquid medium, low concentrations amphiphilous exist separately are subcolloids such as concentration is increased, aggregation occurs over narrow concentration. This aggregation, which may contain 50% more than nanometer, are called miscellaneous because diameter each